Hi everyone, this is Group 23 presentation of H1 Streamflow measurement. This is our group members, Naseh Ameen, Naura Fortuna, Yao Sheng, Nur Afiqah and Muhammad Zidane. Our lecturer is Encik Muhammad Nassir bin Hanapi.
Okay. Then next to the test distribution for the introduction and video completion part, work by Naura Fortuna, and my works are logbooks like preparation, also task coordination. And Ameen work on objective apparatus and also calculation. For the simulation part, the floating object one, Yao Sheng worked on it, and also of the current matter, Afiqah, who the one who did the task. So, okay, so for the book, in the first meeting, we met at 9th May. We discussed about the Streamflow measurement experiment. All the group members are requested to go through the video and information given in our learning related to this experiment. Each group member are required to suggest how we going to distribute the task, and we conclude that we need to hold an online meeting. Next to the group meeting, the tasks are assigned accordingly to all the members. The task deadline is also given so that we might have an additional time to go through and double check everything before submitting. The session also discussed the video recording process, including what should be featured in the video and how long it should last. Members of the group suggest procedure for the experiment. This experiment procedures are discussed and finalized with one info process. And the last meeting, after all the video submit for editing, the subtitle also sent to the editor who will include them into the video. The video content is being double checked. Each participant is expected to complete their own report.
So this is the introduction of this experiment. In hydrological study, it is necessary to quantify the flow of rivers, characteristics such as depth, cross-section, and stream discharge. By using velocity area, we can approach all these parameters and they are being integrated. Our main equation in this experiment is Q equal to V times A, where Q is stream discharge, V is the average velocity, and A is the cross-sectional area of the stream. This experiment also helped us to understand more about conservation of mass. Conservation of mass stated that the discharge at nearby cross-section is the same even though the depth and the velocity are different. In measuring the flow velocities, we are using two methods, which are the current meter and floating object. So next is objectives that will be presented by Naseh Ameen.
And now let's talk about the objectives. We have 5 objectives in our experiment, which are to measure average flow velocity at cross-section, to calculate stream discharge using the concept of velocity area, to strengthen the understanding the conservation of mass concept at river reach, to select stable stream cross-section in river gauging, to use the appropriate safety gears during river gauging. Here we are going to mention the apparatus. We have current meter and stuff gauge and floating object and measuring tape and stopwatch. Now let's move to the calculation. We have firstly current meter approach. Calculate the river discharge using main section or midsection procedure. Float method, determine the total cross-section area to the stream. Use the value and the flow velocity using floating object to calculate stream discharge. And as you see, this is the equation that we have to use.
This is the instrument that we will be using for current meter experiment. This is software and water as our riverside. a ruler as staff gauge, a chopstick as current meter, and a layard as measuring tape.
This is the current meter experiment procedure. Firstly, a river with straight stretch and uniform bed is selected to prevent external factors such as various river depth and river bends from affecting the flow velocity. And we are assuming river flow is in this direction. Next, the width of the river is measured using a measuring tape. Then, the number of intervals between the riverbank is determined and labeled as X. The river depth at every interval X is then measured and labeled as Y. Next, the fan of current meter is submerged into the river, facing the correct direction until it reaches about 0.6 of the river depth. The equipment handler shall not stand in the direction of the river flow. Tree velocity is taken every 10 seconds interval and recorded. The average value of the tree velocity is obtained, and step 6 to step 8 are repeated for the rest of the interval. Lastly, step 1 to step 10 are then repeated for another flow transect at downstream.
So I'm going to explain for the floating object part. So we have this water as a source of water from river, and then we are using this ruler as our staff gauge, and these items as our floating object, and this lanyard as our measuring tape. So now I'm going to explain about the floating object method to measure the stream flow of the river. So firstly, a relatively straight river section is selected. A 3-meter river path is selected and marked. So the width of the river is measured using a measuring tape. The number of intervals between the riverbank is determined and labeled as X. So the river depth at every interval X is measured using the staff gauge and labeled as Y. Then the floating object is put into the river starting from the beginning point of the 3-meter path. So time is started simultaneously as the floating object is released and stopped when the floating object flows past the ending point of the path. Step 6 to step 7 is then repeated twice to get the average value of the time taken for the floating object to flow through 3 meters. The above steps are then repeated at another 3-meter path selected at the downstream of the river.